Hi guys, welcome to this video. In this video, we are going to create a planetary gear assembly using Creo parametric. Let's get started. So first of all, let's click on new, and here let's click on unclick the default template, and this is going to be the assembly. So let's rename our part planetary underscore gear. So then our unit, it will be MMNS design ABS. So at first we are going to assemble all our parts by using axis, as it is a circular part. So in assembly we have to create an axis to start our first part assembly. Okay, so for that I'm just going to create an axis. So axis with the right plane, hold on our control key and select the front plane. So now you see in between right and front we have created an axis. So by using this axis we are going to place all our parts in here. Okay, so let's click on OK. So now you see this is axis 1. So let it be the axis 1, you don't want to rename it. Okay, so now at first we are going to assemble the first part. So the first part, let's go for the working directory. Yeah, so for the first part I am just going to assemble the ring part. Okay, so let's turn on shading with edges. So now let me just move it. This is going to be the pin mechanism. So let's select the axis that we have created and the axis of the ring gear. So now axis coincident is done. So the next thing that we have to place is like the translation. Okay, yeah, so for the translation, let's select the assembly top plane and let's select the front plane of this ring gear. So now it's done. Let's click on OK. Okay, so after placing this part, you see the assembly planes of this ring gear is also visible for us. Okay, so now I'm just going to hide all the datum planes which is belong to the ring gear. So I'm just going to hide everything and let's click on OK. So before that I forgot, like this connection that we have done right now is a pin connection, right? So we have to rename the connection, like the default name is connection 1. So now we have to change that name because we are going to create some servo motors and we are going to create some gear mechanism in here. So it will be difficult if we have connection 1, connection 2, connection 3. It will be very hard for us to understood. So now I'm just going to rename all the connections whichever we are going to do right now. I'm just going to change the name of all the connection as the part name. Okay, so this is the ring gear. So I'm just going to rename it as it is, like ring gear, like enter, and then let's click on OK. Okay, so why I am doing this is, if you go for the application, if you go for the mechanism, inside this we have a connections and joints. So here you can see ring gear planetary gear connection. Okay, so this is the connection name and the assembly name. Okay, so the connection name, if we haven't edited there, so here we will have only connection 1. If we have multiple connection, like we will only able to see connection 1, connection 2, connection 3, connection 4. So that will be very hard. So that's why we have to rename it. Okay, so now let's come back into the model tree. So here we are going to assemble our next part. So our next part, it will be the runner gear. So as the same, we are going to use the pin mechanism, and here select the main axis, assembly axis, and let's select the part axis. Done. So now for the translation, let's select the assembly top plane and let's select the front plane of this runner. Make sure whether this part is aligned to the surface, because I am using mid plane. So if you have created the part using this face, you can directly go for the face coincident itself. Okay, so now let's click on OK. So second part has been placed, and now as I told, I forgot to rename this. So sorry, as a connection. So this is not the connection 1, so this is runner gear. Runner gear. Enter. Okay. So now let's go for our third part. So the third part will be the connector part. So assembly. So this is our gear connector. So yeah, we are going to do the same, but before that I have to disable all these planes, because you see all the planes whichever belong to this runner gear are visible to us. So I'm just going to hide everything, so it may confuse us. And in this runner gear we have one more plane, like a datum plane one we have created inside the part. So I'm just going to hide this part also, this plane also. Okay, so that's fine. Now let's go for the assembly, and this is our gear connector. Let's go for the pin, and now for the pin let's go for the assembly axis and the part axis. Now it is done. Okay, so I have to rotate this, so let's flip it here itself. Let's do like this. So this is our assembly axis and part axis. So now it is done. So make sure you are placing the component on the opposite direction. Okay, so now for the translation I have some specific value. So for the translation I'm just going to select the mid plane here. So this is our assembly top plane and the face of this gear connector. So this is not going to be the coincident relationship. I'm just going to make it as a distance. So the distance value, as like you can measure it on the main gear that you are going to assemble here. Okay, so my main gear length is 30, but here you see that the mid plane, like this is not a surface coincident, we are using the plane. So from the face till the plane this length is 5. So I'm just going to add 30 plus 5, so that will be 35. Okay, so now if we go for analysis, if we go for the distance, we can able to measure from the surface to the surface, it will be 30. So that is what I want. Okay, so it's done. And like the way I have forgot about the connection name, so this connection, it will be gear connector. Done. Okay, so now let's hide all these plates, but yeah, so we can hide it because we just need axis, we don't want any planes in here. So let's hide all these. Okay, so because we need this axis to place one more next main gears, right? So next assembly is going to be the main gears. So go for the model. Now I'm just going to select the main gear. So this is what. Okay, so now same pin mechanism. So select this axis and select this axis. Okay, so then the next, select this face and select this face. So this is for the translation. Okay, so now our part is assembled, right? So let's click on OK. So before that I forgot to rename the connection. So this will be main gear 1, main gear, let me choose 01. Okay, so main gear 01. So I'm just going to copy this for future. Okay, so now I'm just going to repeat this. Go for the repeat, select axis and surface, add. So let's select one more axis, surface, select this axis, select this surface. So we have assembled all the parts, but here we have to change the connection name here. So in the placement we have a default name of main gear 1. So this is not main gear 1, this is 2. Okay, and here it will be 3. Okay, so now we have assembled everything. So once go for the application mechanism, and let me check whether we have all the joints as a very like a lineup names. Okay, so this is ring gear, runner gear, gear connector, main gear 1, main gear 2 and main gear 3. Okay, good. So because if we haven't renamed there, here we have only connection 1, connection 2, connection 3. So that will be very hard for us. Okay, so now it's done. So the next thing here is for the gear mechanism, so we have to find out the like a diameter for the like pitch diameter for all these circles. Okay, so I'm just going to select the surface, go for the sketch, and go for the sketch view. So here let's draw a circle. Let's hide all these data planes for now. Let's draw a circle. Okay, so here for the circle I'm going to make it as 11.68. okay, so this is a mid, or else you can go up with your own values also. Okay, no worries. So let me see which is my gear 1. Okay, this is my gear 1. So for the gear 1, this should intersect with the center circle. Okay, so then one more circle which is going to intersect with the like this ring gear. Okay, outside ring gear. So let's intersect it, tangent. Okay, good. So now here we have to measure all these three diameter values. Okay, so when we are going to use the gear mechanism, if we are going to connect two gears like this blue gear and this yellow gear, like we have to mention the diameter of the gear. Okay, so if this gear diameter is 11.68, we have to mention there, and on the gear 2 we have to mention this gear diameter. So for that we have to measure everything before. So now we have a value of 11.68. okay, I note it down. So the next dimension, so this is our main gear. So the main gear diameter, it will be like the radius is 12.16, so the diameter will be 24.32. okay, so everything note it down, or else if you have enough experience with this annonate, you can directly go for the annonate and you can make a note on it, so that will be very clear for you. Okay, so if that's not possible, no worries, like follow my steps. Okay, so this is fine. So the next diameter is the outer circle, so this is 60.32. okay, so this is radius, so we have to multiply with 2. okay, done. So after measuring all this, you can directly close the sketch, or if you don't want the sketch, you can delete this also, no worries. So this is just for our reference. So for now I'm just going to make it hide. okay, so now everything is done. So let me just go for the top view. I'll just drag it out like this. Okay, good. Okay, so now let's go for the sorry, like we have done our join, so now we have to go for the gear parts. So application, now let's go for the mechanism. So now we are going to create gears in here. okay, so for the gear we are going to like a gear mechanism, we are going to arrange a gear mechanism for over 6 gears. okay, so 6 gear connection will be there. So one is from the runner to the gear 1, from the runner to the gear 2, from the runner to the gear 3. So this will be 3, and the next gear pair will be from the runner 1, sorry, from the main gear 1 to the ring gear, gear 2 to the ring, gear T to the ring. okay, so this is what we are going to do. Around 6 gear pair we are going to do right now. okay, so the first gear pair, like I recommend you guys to not to select anywhere in this part. okay, use the connection itself, so that will be very easy for you. okay, so the first, let me open the joint here. okay, so the first gear pair, so I'm just going to rename this gear pair, so that will be very easy for us. So this gear pair is going to be the runner and the gear 1. So let's make it as a R for the runner, runner to gear 1. okay, or R means runner, G means gear 01. So for our own reference. okay, now I'm just going to select the first gear, so that is going to be my runner gear. So for the runner, let's click on the runner gear. Here we have to select the rotational axis. So now you see we have selected the runner gear. okay, so now, okay, just a minute. okay, now this is fine. So now we have to enter the diameter of the gear here. okay, so for the runner gear we have a diameter value, so that will be 11.68. so in the sketch we have measured, right? So that's what we have to mention here. okay, so next, it will be gear 2. So from the runner to the gear 1. Okay, so now let's close this. So this is main gear 1, so to the main gear 1 rotational axis. Okay, so then what's our main gear 1 diameter? So that will be 24 point, okay, 24, just a minute guys, 24.32. Yeah, that's fine. Done. So once you done this value, first of all let's go for the gear 1 and let's see the arrow, like we have to, okay, that's fine. So for the gear 2, the arrow is towards inside. Okay, that's fine. So let's click on OK. So now we have to repeat everything one more time also. Okay, so yeah, that's fine. So let's close this and now let's go for the gear. Now this will be runner to gear 2, right? So this we have to select the rotational axis of the runner and the runner dia. Where is the runner dia? So it will be 11.68, and the gear 2, it will be main gear 2 rotational axis. So now main gear 2 diameter 24.32, done, and then okay. So 2 gear pairs are done, as you can see here, green line. So now we have to do that for third gear. So runner to gear 3. Now we have to select the runner and the runner diameter will be 11.68, and next for the gear 2. So for the gear 2 we are going to select the main gear rotational axis, so that will be 24.32. so let's see, 11.68 and 24.32. Yep, good. So now let's get into the gears. Now you can see runner to gear 1, runner to gear 2, runner to gear 3. So we have almost done 3 gear pairs here. So now we have to go for the ring with the gear 1s and ring with the gear 2, ring with the gear 3. So that is what we are going to do. So now let's go for the gears again. So now this is going to be ring to gear 1, like, okay. So now we have to select the ring gear axis. Okay, done. So then the ring gear diameter, that will be 60.32 as we have measured on our sketch itself. Okay, so the next thing is gear 2. So the gear 2 will be the main gear 1 rotational axis. So our main gear rotational axis, like that's the diameter will be 24.32, and done. So next one more gear, that will be, sorry, ring to gear 2. Okay, so now we have to select the ring joint and the diameter will be 60.32, and the next it will be gear 2. So the gear 2 will be main gear 2, select the rotational axis, and here the diameter will be 24.32 again, and let's click on OK. Now the final gear connection, so that will be ring to gear 3, right? Sorry, yeah, G3. Okay, good. So where is our ring? So ring rotational axis, so the ring diameter 60.32, good. And our gear 2, so that will be our final main gear. So the final main gear diameter will be 24.32, and let me check it for one more time. Done. So now we assembled our point and we have made our connections, and now just now we have made our gear connections here. So let me have a look on it, and you see we have over 6 gear connections over here. One is ring to gear 1, next one is ring to gear 2, sorry, runner to gear 1, runner to gear 2, runner to gear 3, and ring to gear 1, ring to gear 2, and ring to gear 3. Okay, so now we have done all those connections here. So the next thing that we are going to do here is the servo motors. So now we have to create servo motor for all these pin joints, wherever all these connections wherever we have created. Okay, so now let's close the gears. Let's go for the connections one more time. So now at first I'm just going to create a servo motor for the ring gear. So click on the rotational axis. Now we have the servo motor, and in this servo motor, let's go for the profile details and go for the change it to the angular velocity. And now our coefficient like 5 degrees per second. Okay, so 5 degrees per second, and let me have a look on it. It's looking good. Done. So now here we have motor 1. So like that we have to create around 6 motors. So if we have motor 1, motor 2, motor 3, so that will be very difficult. So I'm just going to rename this. Go under the properties. I'm just going to rename this. So this is going to be the ring motor, right? So ring motor. Done, and click on OK. So now we have our ring motor. So now we have to create like this for all these things. So we have done for the ring. So next, runner, rotational axis, go for the servo motor. So now it will be angular velocity, but the rotational degree, that will be different. So here we have 15. For the ring it will be 5, and for the like sorry, what is this? I forgot. Sorry. So the runner gear, for the runner gear it will be 15, and for the main gears it will be 10. Okay, and for this back connector it will be around 8. Okay, so now we have entered our coefficient. It will be angular velocity, and we are violating our part, and then we have to change the name. Okay, so this is our runner gear. So let's go for runner motor. Don't forget to click on your enter, because if you haven't clicked your enter means it won't rename. Okay, so the next it will be our like gear connector. So let's close this gear connector. We have to go for the servos, and here we have angular velocity, and like I said before, the rotational will be 8 degrees per second with angular velocity. Okay, and now we are going to rename it. So gear connector motor, so that will be very big. So let's go for connector motor. Right, done. So now we have our 3 servo motors here. So the next one will be the main gears. So that we have to go for the main gear 1, rotational axis, servo motors, and here velocity. So now this will be 10 degrees per second. So this will be same for all these 3 gears, 10 degrees per second. Good. Sorry, I forgot to rename it. So now how can we rename it, like main gear motor, or let's go for G01, like, or else let's go for YAM main gear 01 motor. Control all, copy, enter. Done. So main gear 1 motor, and then let's close this. So next it will be main gear 2. So velocity, and it will be 10, and on the properties tab let's paste which we have copied, and it will be main gear 2 motor. Done, and I need to just verify whether you have a 10 value. Good. So now the final motor will be on the main gear 3 servo motors. Here we have angular velocity, and coefficient will be 10. Properties, paste it, and this will be main gear 3. Okay, so now we have done everything. Like, let me check. 6 connection joints, and 6 gear joints, and 6 servo motors. Done. So now we can able to run our gear. So now we have to verify whether all the things that we have done is right. So okay, let it be the position type, and here we have all these servo motors, but we don't want to run everything right now. At first I'm just going to run the runner motor, because that's going to be our main motor here. So in time, let's keep it 100 and let's run this. Okay, good. So this is our first run type. So now let's go for our motors again. So now I am just going to run two motors here. Okay, so the first one is runner motor and the next one is a ring motor. Okay, so the runner and the ring. So our end time, let it be 100, and let's reduce, let's increase the frame rate. So increasing the frame rate will slow down the rotation. Okay, so let's see. Okay, so now you see it looks really good, right? So this is how it works, and then you can able to change everything here. Okay, so now let me go for it. So first one is runner motor, and the next one is, let's go for the like a gear 1 motor. So here we have 100, and now you see, so this is one type of rotation. So what else is, I think the perfect rotation will comes when we have a runner and when we have a ring. Okay, so let's keep it as, sorry, 100, and let's keep it as 30. Done. So that's all, guys. So thanks for watching, and if you want more videos related mechanical engineering or any other content, you can comment below so that I will upload more videos based on that. So thank you, guys. We will see the next video with a very interesting content. Until then, bye.